Hello class 8, we'll now be doing our lessons on the board itself rather than doing it on paper and then me trying to explain you things there. Okay, so the topic that we're going to start with is mechanical energy. We've looked into different forms of energy, so many different forms of energy, and we also looked into their interconversion, one form of energy getting converted to the other. Now here is one specific form of energy which is mechanical energy that we are going to discuss about. How do you define mechanical energy? Mechanical energy is the energy possessed by a body due to its state of rest or motion. So the energy a body possesses, like this piece of chalk possesses right now, because of its position or because of it being at rest. Anything that is at rest also possesses energy, remember, and the energy it possesses is mechanical energy. Also, if the body is in motion, if I throw this piece of chalk, okay, and it hits somebody on the head, alright, so a body in motion also possesses energy, and the energy a body possesses also because of its motion is also mechanical energy. So the energy, remember, that a body at rest possesses or a body in motion produces is what, or not produces, possesses, is what is called your mechanical energy. Now, as you can see in this flow chart over here, mechanical energy can be of two kinds. One is called kinetic energy and the other is called potential energy. Now, what is kinetic energy? Kinetic energy is the energy possessed by a body which is in motion. Okay, the word kinetic itself means in motion. So wherever the name itself therefore is telling us that this is the energy possessed by a body in motion, because kinetic means in motion. Any moving body possesses kinetic energy, remember. That is why I hit someone with this piece of chalk, it hits here and it peels. Alright, someone shoots a bullet, okay, and the bullet obviously kills the person by penetrating into the person's body. So the energy that the bullet possesses because of its motion is kinetic energy. Okay, unfortunately someone gets hit by a moving car, the moving car possesses kinetic energy, therefore it could be severe or fatal for that person also. So any moving body possesses energy, mechanical energy, alright, and which form of mechanical energy any moving body possesses? It is kinetic energy. So you will say the energy possessed by a moving body is what is called kinetic energy. The kinetic energy of any moving body is given by half mv squared, where m is the mass of the body and v is the velocity or the speed the body possesses. So don't forget this expression, you need this to do numericals. Kinetic energy is half mv squared. Whereas the other form of mechanical energy is potential energy, and this is the form of energy which is possessed by a body at rest. Okay, so any body that possesses energy because of it being at rest is what's called potential energy. Now, potential energy itself can be of two kinds. One is called gravitational potential energy and the other is called elastic potential energy. Now, what is gravitational potential energy? Listen to me carefully. The energy possessed, of course, by a body at rest, because potential energy is the energy possessed by a body at rest. So both are energies which are possessed by bodies at rest, of course. But the energy possessed by a body at rest due to its position, meaning due to its height from the ground. Higher the body is from the ground, more is its gravitational potential energy. So the potential energy possessed by a body due to its position or height from the ground is what is called gravitational potential energy. Now, you must have noticed that if, let me bring a bigger body. What is that bigger body? Okay. So I have this small piece of tile over here. Okay. So if I drop this tile, you can only hear the sound. You won't see the picture, of course. So you heard that sound. Okay, now let us drop this tile from over here. So you heard a bigger sound. Alright, so what is happening? Why did we hear a louder sound in the second case? Why? Because higher the body is from the ground, the more will be its gravitational potential energy. So higher the position of the body from the ground, so higher will be the gravitational potential energy. We can jump from a small height. Okay, we can jump from a stool or from a tabletop, but we cannot jump from 2-storied or 3-storied high building. Why? Because on top of a 2 or 3-storied high building, we are farther distance away from the ground. We are high above the ground, and thereby we possess more gravitational potential energy. So when we jump from 2-3-storied building, okay, so what happens is there's every chance that we'll break our head, our leg, okay, and we could also die. Alright, simply because we possess more gravitational potential energy. So mind you, the potential energy possessed by a body due to its height from the ground or due to its position from the ground is what is called gravitational potential energy. You can write that, copy that down in your exercise book, of course. Now, what is elastic potential energy? This is also potential energy, which means the energy possessed by a body at rest. Now, what is special about elastic potential energy is, this is the potential energy possessed by a body due to its state. Due to its state, meaning whether the body is compressed or stretched or bent. Okay, to give you an example, a catapult or a rubber band. Okay, when you pull a rubber band, alright, say you have a catapult and you have a stone also, so you pull it and when you let it go, what happens? The stone flies off. Why? Because the stretched rubber in the catapult, alright, what? It possesses elastic potential energy because it is stretched. Likewise, you stretch a rubber band and hit your hand, okay, or your friend's hand, it pains. Alright, why? Because the stretched rubber band possesses elastic potential energy. Likewise, a bow and an arrow. When you pull the string of the bow and you pull the arrow backwards, what is happening? You are giving it more elastic potential energy. The bow possesses elastic potential energy. That is why when you let the arrow loose, it flies off because of the elastic potential energy. The bow possesses, not the boy, the bow possesses. Alright, so remember, elastic potential energy is the potential energy possessed by a body due to its state. State meaning again how compressed or how stretched the body is. Likewise, a spring, to give you another example, a spring. Alright, if you have a spring, okay, and you place a ball on top of the spring and you compress the spring, you let the spring loose, the spring itself jumps off and thereby the ball also jumps off. Why? Because the compressed spring will possess more elastic potential energy. Now, in your syllabus, you only need to remember the expression for gravitational potential energy. Just understand what elastic potential energy is, what gravitational potential energy is, what kinetic energy is. Alright? You need to, of course, remember the expression for kinetic energy, which is half mv squared, and also to remember the expression for gravitational potential energy, which I have depicted over here. P dot E means this is gravitational potential energy. This is mgh, where I'm writing over here. M is the mass of the body. G is acceleration due to gravity. You've studied about this. Acceleration due to gravity. The value of acceleration due to gravity is 9.8 meters per second square. Meter per second squared is the unit of acceleration, and h is the height from the ground. Alright, likewise over here, m is the mass of the body. Let me write v is the velocity or the speed of the body. Velocity of the body. Okay, class 8. And by the way, you can see from this expression itself, more is the velocity of the body, more kinetic energy it possesses. That is, faster a car is traveling, okay, more kinetic energy the car will have. Okay? Don't forget that. So let me erase this and let me tell you. So thereby, let me tell you the factors on which kinetic energy depends. There are two factors. Since kinetic energy is half mv squared, don't forget the expression. Kinetic energy is half mv squared. That's the expression of kinetic energy. Let me erase these things. Kinetic energy depends on the first is mass of the body. You can see from this expression itself, the kinetic energy is half mv squared. Alright, so it depends on the mass, and the other factor is velocity. Now, how does it depend on the mass? More the mass of the body, more the kinetic energy. Remember that. Okay, so to say, if I have a small ball and a big ball, okay, one ball is made up of iron, okay, which has a bigger mass, and the other ball is made up of plastic. I roll both of those two balls with the same velocity, with the same speed. I throw both of the balls. To stop which of the balls will it be difficult for you? Obviously the ball, iron ball, okay, they are both, although both are moving with the same velocity, the iron ball, since it possesses more mass, therefore it will have more kinetic energy, and thereby it will be difficult for us to stop it. Remember that. So more the mass, more will be the kinetic energy. The other factor is, like I've already mentioned, velocity of the body. Please do copy these things, class 8 in exercise book. I'm telling you again. Okay. So how does it depend on the velocity of the body? I've already told you. More is the speed, or you can also call it velocity. More is the speed or velocity of the body, more will be its kinetic energy. More is the speed or velocity of the body, more is the kinetic energy. Okay, class 8. So do remember these two factors on which kinetic energy depends. So I think this much will do for this video. We'll continue in the next video. Thank you.